Hi, this is Mrs. Villette, and in this video I'm going to show you a very simple way that you can visualize a disease outbreak and what people are talking about when they're talking about flattening the curve. So this is a great activity that you can do with kids, sort of regardless of their mathematical ability, as long as you can visually explain to them what the graph looks like. So you notice that I've got some grid paper, and I'm not actually going to do a graph yet. What I'm going to do instead is I'm going to simulate some rounds of people who have a disease interacting with each other. So I'm going to start by numbering my patients, and I'm going to assume I have 20 people in my population who could get sick. So what I have on the left here is I have my people just numbered 1 through 20, and then I have my rounds here, and I'm also going to go through 20 rounds of infection. And what I did to simulate this activity is I just used a random number generator. So I went to random.org and I chose the random integer generator and had it choose a number between 1 and 20. And that's going to be my first person who's infected. So this is what it'll look like when you interact with the website. So I had it choose one random integer, and each integer had a value between 1 and 20. And as I went through this activity, I just kept hitting the back button, and all I'm going to end up changing is how many random numbers I generate. So I happened to get patient number 8 as my first random number, so that is my patient 0. Now there's a couple of assumptions that you can work under. You can just be counting the total number of people who have been infected, or you can count how many people are infected at one time. So I'm going to work under an assumption that it takes 4 rounds for somebody to be fully cured. So patient 8 was first infected in round 0, and by round 3 they are fully cured. So I'm going to go ahead and cross off all future chances of them getting infected. So in round number 0, I have 1 person infected. What I'm going to do next is I'm going to go to the random number generator, and I am going to have it select a random number. So I'm taking this infected person and I'm having them go out and interact with one random person and see who they infect. And who I got was number 16. So now in round 2, number 8 and number 16 are infected. I have 2 people infected, and I'm going to go ahead and infect 16 all the way through their 4 rounds and then have them cured. Now that I have 2 people infected, I'm going to send those 2 people out to interact with 2 random people and see who they interact with. And they interacted with patient 4. So here's patient 4. And they interacted with patient 12. So here's patient 12. So now we have 4 people infected. And we'll go ahead and we will kind of close these people out so I make sure that I know when they get better. Okay, so we're going to keep on doing this, and I'm just going to show you what the result looks like and show you how many people were infected after each round. So right now what I'm looking at is we're in round 5 right now, and we have 12 people infected. And one thing that I want you to notice is if I pull a random number, let's say in this round I pulled the number 17 and I saw that 17 was already infected, that's fine. They're not going to be reinfected or made sicker, so that random interaction doesn't result in a new infection. You can see at first it looked like things were pretty much doubling. I went from 1 to 2 to 4 and then to 6, which is not quite double. And then I'm not really doubling anymore. And part of what's happening is when we pull these random numbers, if we think about these as interactions, we're starting to interact with people who are already infected, and so we're not resulting in new infections. So you'll often see people saying that it's exponential. Well, it's exponential up into a point, and usually the point where it kind of changes is right around the halfway mark, where half of the people are infected at once. And what you're going to see is that we're going to start to see fewer cases in a minute, but we're actually going to reach our maximum in this next round. So I'm continuing to just pull these random numbers, and I'm marking off my chart and then counting how many people are sick. So I'm going to go ahead and skip a few rounds ahead. So let's take a look at where we are now. What I actually added is I added a circling in blue to see the first time somebody was infected. So we were at 12, and then in the 6th stage, we ended up with 3 new infections, but some people got better, so we only had 14 cases total. And then in the next stage, we ended up with 2 new infections, but we also had 2 people who got better, so still at 14. In the next round, we can see everybody at this point has been infected. So if I look across, every single number has been infected. So there's no new people to infect. So now we're just sort of waiting for the disease to run its course for people to get better. So we can just go through and count that we have 10 left here, and then we have 6, and then 2, and then finally we should be down to 0 after 11 rounds of infection. Everybody is better. And you can hear that noise in the background is my cat. So that's kind of the first part of the activity. I'm going to show you what the graph of that looks like. So here are the points plotted. On the left here, I've got the number of rounds, and then on the right, or the y coordinate, I've got how many people are infected. So here's kind of a rough sketch of our curve of people who are infected. And when we talk about flattening the curve, what we're wanting to do is kind of stretch that out so that it looks more like that. So one way that you can do this is run your simulation again. Run it basically the same way, have your 20 people, but instead of having each infected person go out and interact with one person, what I want you to do in the next simulation, and this is left as an exercise for you, is I want you to only have half of the people interact. So what I want you to try for this next round is I still want to start with 20 people total, and you're going to use a random number generator, or you can even pull numbers out of a hat to pick one random person to infect at first. You're still going to be infected for 4 rounds, and you cannot be reinfected. But instead, you're going to have half of the infected persons rounded up, go out and interact. So if you have one infected person, there's still going to be 1 interaction in the next round. But if you have 2 infected people, half of that would be 1. You're going to have 1 interaction. If you have 5 people, you're going to randomly choose 3 numbers. So you don't have to use a random number generator. You could just have numbers in a hat and pull them out. Keep track of it the same way, just on a grid, and then plot your new points. So I'm going to show you what happened when I did this. So these are my results. Again, that first curve is the first round, where we started with 1 infected person, and then we had all of those interactions, and they got new people sick. And then here is kind of our modification, where only half of the people interact. And what you can see is that the biggest difference is the maximum total number of people infected at a time was 14, the original case, and here it's only 7. So we halved the number of people who are infected at any given time. I want you to think about what would happen if you only had a quarter of the infected people go out and interact. So that's why social distancing is very important. Again, I intended this to be an activity, something that you could do with your kids. Maybe you're trying to do some academic time with them while we're all social distancing. And I want to say I am not an epidemiologist. I'm a mathematician. The basis of this is a logistic differential equation, and everything I did was completely made up. The 20 people, the 4 days, none of this has to do with COVID-19 in particular, just a general model for disease outbreak.